So we're just going to look at the derivation of the masses from this reaction. So we've got 2 moles of potassium iodides, and that tells us in the balanced equation. So 2 moles of potassium iodide plus 1 mole of lead nitrate would give us 1 mole of lead iodide and 2 moles of potassium nitrate. So the question tells us that we start out with 13.28 grams of potassium iodide. Okay, and I've worked out the mass per mole, or the relative molecular mass, for each of these compounds. So we start out with 13.28 grams of potassium iodide. We need to figure out how many moles that is in order to do the calculation. And in order to do that, we can use the molar mass, or the relative molecular mass, as a conversion factor. So we know that these are mass per mole. So that means that 166 grams of potassium iodide is 1 mole of potassium iodide. So we can set up our conversion factor, and that would be 1 mole of potassium iodide is 166 grams of potassium iodide. So either way we write that, we're talking about the same thing. So we can use that as a conversion factor. Now we want the conversion factor to be set up so that grams of potassium iodide cancels out. So we need 1 on the top and 1 on the bottom. That's why I've set it up this way, that 1 mole of potassium iodide is 166 grams of potassium iodide. I could also have flipped it the other way around to use that as a conversion factor, but I've gone for this layout because I want the grams of potassium iodide to cancel out. And that will leave me with 0.08, notice the units that we have on the top, moles of potassium iodide. Okay, so now I know how many moles of potassium iodide I'm starting with. I'm going to look at the equation to find the molar ratio between the potassium iodide, which is the limiting reactant. And if you're not sure about limiting reactants, watch the video that follows this one. The limiting reactant is the reactant that gets used up first. So we need more of the potassium iodide than we do of the lead nitrate. So 2 moles of potassium iodide produces 1 mole of lead iodide. So the molar ratio is 2 moles of potassium iodide to 1 mole of lead iodide. So we put 2 moles in of potassium iodide, we get 1 mole out of lead iodide. So now we need to scale that to the actual quantities that we have. So if we have 0.08 moles of potassium iodide, then that will give us half the amount of moles. So we're going to have 0.04 moles of lead iodides coming out of the reaction as the product. Okay, because the ratio is 2 to 1. So the ratio here has to be 2 to 1. We're just scaling it down to the exact amount of moles that we've got. Now that we know the amount of moles of lead iodide that is produced, we can work out how many grams that would be using the mass per mole, or the relative molecular mass, as a conversion factor. So we have 0.04 moles of lead iodide, and we're going to use our conversion factor. Remember, we need moles of lead iodide to be on the bottom this time. So we're going to say that 461 grams of lead iodide is the same as 1 mole of lead iodide. And notice now we've got moles of lead iodide on the top there, moles of lead iodide on the bottom there. We're left with grams of lead iodide, which is what we're wanting to find out. And if we do this calculation, we end up with 18.44 grams of lead iodide. And now that we've got that information, we can go ahead and work out the percent yield.